Ta-da! Hey, hello guys. Let's solve today's LeetCode daily challenge. Today, yeah. So I'm just planning to be consistent for this whole month. Let's start from a day one. Okay, go 2182. Medium on. Find the safest path in a grid. Okay. For given 2D grid. Okay, where is represent if it is a 1, then the cell contains a thief in it, and then 0 represents an empty cell. Okay. Initially, your position is 0 comma 0. In one move you can move any of adjacent cell in the grid in okay, including the thief cell. The safest factor of a path on a grid is defined as a minimum Manhattan distance from one cell in a path to any thief in a grid. Okay, safeness of factor is defined as the minimum Manhattan distance between any cell in the path to the thief in the grid. Okay, return the maximum safeness factor of all paths, okay, leading to n minus 1. Okay, the cell, okay, we can go this direction, Manhattan distance, okay, blah blah blah. Okay, that's fine. Okay, so the grid of length of 400 or 400 seems okay. Seems that I need to use the type of, okay, seems okay. So seems our yam and yan should be 400, so which means that at max that would be 400 times of 400, right? Which is probably we can say like 16 times 0 times 40. Oh my god, this is 16. Okay, 16 times of 10 power 4, which is good. Okay, so actually, what this question was like, we need to start from the from the left, top left, and then we need to go to the bottom right. So actually, in this, we need to return the maximum factor, maximum safeness of the factor, which means that, so let's say, example, if you are just taking this path, the safeness of each cell was defined as the absolute difference between the both the cells. Okay, the absolute difference that we can calculate based on the x1 minus x2, absolute of x1 minus x2 plus y plus y1 minus y2, like the same Manhattan distance formula. So yeah, so actually for this cell the minimum distance was 3, and then this cell minimum distance was 4, and then this was 2, and then at the end 2 is that. Okay, I was thinking about like, okay, I was thinking about like, so for each cell we need to know what is the minimum factor, right? So yeah, I got something like so. Um, for each cell, compute the for each cell compute we can say, yeah, we can say compute safeness for each cell. Okay, compute the safeness for each cell, and then find um, find maximum factor, like find maximum safeness to reach from 0 to m minus, from m minus 1 and n minus 1, right? So basically this is like, if you take this as example, no, this is okay. Now if you take this as example, the maximum safeness of this, sorry, the minimum safeness, compute the we can yeah, compute the minimum safeness for each cell. So for this cell the safeness was 3, and then for this cell the safeness was 4, and then 2, so which is exactly as 2, and then for this cell safeness was 1, and then for this cell safeness was 0, and then if you take this cell as example, this safeness was 2, which is minimum, and then this is 4, and then this is 1 2 3, I think, and then for this cell the safeness was 2, and then for this safeness was 1, then if you go to safeness was 1 2, and then if I was not wrong 3, and then 2 again, and then if you take this as example 0 1 2 and 3. So yeah, So after computing the safeness of each cell, this is a step one, and then actually what is the step two was like you need to find the maximum safeness that we can maximum value. We can take maximum value, max value, max value from left, from we can say from start to end, right? So if we take this as start and then we can do a simple extra, we can simple extra or BFS to reach from start to end. Yeah, so this is the code approach. At first we can just go with the step one. Okay. Oh, they have given us grid. I don't like the format like it. Okay, get up 0 dot size of. I want to make it capital. Okay. Then we can just define it as distance. Okay, and then we need to fill each value as maximum value, right? So we can just define each row. Okay, what was it? Fill that. Sorry, it's arrays that fill of like a row and then integer that fill each cell as max value at first. And then just do the math. You need from Q. I was just planning to segregate into a two different methods because you can just do. Yeah. Okay. Right, this will return the distance, compute, safeness. So this is a grid of grid, list of list. What do we need? I think we can pass the size of the grid as well. So instead of just doing all the stuff over here, just do whatever thing we need and then get it over here as this distance. Complete safeness. I think that's some type of complete safeness. Pass the grid over here and yarn. Yeah, we are good enough. So what this queue is going to hold? This queue is going to hold index and then what else we actually need with them. So yeah, so from so actually how we are going to compute the safeness is like at first we are just going to insert all the thief cell into the queue. It's basically like minimum time, basically like the rotten oranges or something. I forgot the question. So the same kind of stuff. We need the time. We need time, something minimum time for the thief to reach this cell as well. Okay. I would just prefer this where define all the direction. Make it a static, so don't want to just create it for each object. So directions, make this so this is for the top, and then do it for down, and then left, and then at last the right. Yeah, good enough. So we can just make this name it as Q, and then we can just make safeness. Make it as a heap and then define okay, and then say like we need the minimum time for each set, right? So compare based on the time. Here index 2 and then we have 2. Good enough. And then before that iterate each cell Okay. Yeah. So just check if my grid dot get of 0 get of I, and then if my current cell was P, what I need to do? I need to insert the current cell into the queue, right? So here the time was 0 because the thief was in at the same cell, right? So make our distance of the current cell as 0. Yeah, now we start enjoying the good part of this question. While q dots I do until then, take the current cell. Okay, take the current cell, and then for go it for each direction. Like what we can do? Just do like, okay, we can just have some. We can just burn it before, like if we will only process this if what is distance, right? What could be the distance of this to this? Was what both were saying? X minus y. I was thinking what the distance of 1. This is 0 of 4. 0 of 4, and then this is 1 of 3. 1 of 3. So 1 plus 1, right? So which is 2. So yeah. So our approach will work like, okay. It's simply like if my current, we can just do it like if distance of, okay, I need xi ing equation into my current index was this, and then what is if distance of ij, if my current of I current of 2, right? Yep. So if my current of 2, if this was less than this current time, then I can able to go it over here. This was the safest case, like, so for this one the value would be integer maximum the current time, and then here when depositing the current was 0 for this cell, and then if the one more addition of extra time, which can be this continues to get satisfied, and then go over the childs. I think we don't. Are we? Do we need this actually? I think we need this, but not over here. Because we need to make sure before adding the every element into queue. Make sure like we didn't doing we are not crossing the same cell again and again. That's what I'm just trying to do. Okay, take the current direction, and then take the current cell y ing. Okay, check if this is not going the out of bounds, and then distance of x and y. This is the part. This is the function y. Which is less than my current of 1 plus 1. I will add it. So my q dot add of of x of y, and then current of 1 plus 1, then current of 2 plus 1, that is the time, and then make sure that and update the distance as well. Yep, here we go, return the distance. Okay, and then do the same DFS path again. What I'm just going to do is like I'm going to copy the same path. So actually here the step 1 was done. So for step 2, the same. What is the minimum time to reach from the start to end cell? This is a standard. This is a standard ASA, right? I mean the standard question, right? So we don't need this, and then we can just name it as Q, and then yeah, we are just going to do the same in time as well. Here we are just going to add int of like 0 of the start cell, and then here we need to pass the distance of the current what the distance. So for this case, the time would be 3. So do the same operation again and again, and then check. That's one case. If I was in if I was here -1, and then if we already reached the last cell, then we can simply return the current time what we just processed. Yeah, I think this is good enough. No, so actually here what we need to do is we need to just know the maximum, right? So maximum factor, right? So here we need to pass what is it? Yeah, here we need to pass the maximum factor. So we need to just do it. Okay, the maximum factor. And then here we are not doing like updating the value like +1, all those stuffs. Or we can just move to the next cell. We need to add everything again, like we need to add each cell. So instead of doing it here, take the minimum max of maximum. No, we need to take the minimum value of the current, already the parent value, as well as distance of the current cell as well. So whatever. So if we are doing this, we can able that could be leads to be we are just processing the same cell again and again, right? So how we can just cut that part. How we can just do this? We can just make distance of 0. We can just make the visitor cell as -1. Okay, and then distance of x and y which is not equal to -1, which is not visitor, then we can just process it. Okay, see, this will work. Okay, nice. You can try and submit it. Good one. Why this current output is not working? Okay, because we forgot to add the array over here. Nice. Okay, then we forgot to check the upper bound as well. I think in down 2 we forgot to do the same. Memory limit exceeded. Nice. I think we are just processing the same cell again and again. Where it's happening? Okay, if it is 1, we are just adding it into the queue, else we are just removing the part and then taking it. Okay, so here we are just do this again and again. I think this doesn't seem good because distance of I was less than of the current one. Right, I'll just comment this part and check where we are just. See, this is fine. I think something wrong in our step 2. Okay, removing it. Okay, the same. We have forgot to update. We have forgot to make it a visitor. Yeah, we are good enough. Check. Okay, there is no submission as previously. Try submitting it. So actually this question is quite simple, like just divide the question into 2 parts, like the step 1 and then the step 2. Okay, the step 1 is like minimum time for each cell, where is the nearest thief was present over there, After computing the first part, in the second part it was like, hey, I was standing in the top left. What is the maximum time that I can just reach from top left to bottom right with the distance which I have already computed? Okay, let's check like how I just did it before. I did it like when 2 years back. Nice. First, okay. Seems like I did it in the same way. I have addition on something like that. I was little confused over here. Like, what is the computation time for this one is 318, right? 318. I was thinking like I was thinking to add this condition from here as well. If my current cell, right? So if my current cell value which is being not updated, so it was like if my current distance value, if we are doing it, then definitely this would be the case, right? Yeah. So I was thinking whether to what should do, what should I need to do, like there will be some cases like we are just processing the same cell again and again even with extra as well. Okay, good enough. Hope you guys understood this. Stay consistent. Bye.